So we're told to find a logistic regression model parameters that best fit this data using gradient descent. So the logistic regression model parameters is dependent on two formulas. The first one is the sigma function, which is giving us h theta x, where x is a data point. In this case, we have three data points, 1, 2, and 3, equals to 1 over 1 plus e raised to power negative theta transpose times x. I will explain this. You can just equate this to z, so you don't have to write that for me. I will explain that. And then the second thing we're going to be dependent on is the gradient of cost function, which is given as this, in which I is row and j is column. So that's just how to interpret this. First thing is, let us find this, right? So theta, in this case, we're going to have three parameters for theta. It's going to be theta naught, theta 1, and theta 2. Now theta naught is basically just a bias term, and then we have our input features here. Well, we're going to do something odd. We're going to add what we call a bias term again to the input x to accommodate this. So now let's say, like I said, let's equate this to z. So let's say z will be equals to, what's the transpose of this? Simply just write it as a row times this as a column. Now simply just multiply them like you multiply in normal matrix. It will be theta naught times 1 plus theta 1 times x1 plus theta 2 times x2 equals to z. That is it. So this will be the formula we'll be using there. So for our first data point, we say h of theta x1. This x1 in this case represents data point. So our first data point is this. In this case, our x1 is what? 1, and our x2 is 2. This x1 and x2 here represent input features. There's will be 1 over 1 plus e raised to power negative theta naught, which is 0. Okay, it's true. Sorry, I forgot. We're supposed to initialize our theta naught, theta 1, and theta 2. Basically, just initialize them as 0, 0, 0. So it's going to be 0 times 1 plus 0 times, what's x1 in this case? 1 plus 0 times 2. That's just it. So if you solve this, you're going to get your answer at 0.5. And for our second data point 2, it's going to be 1 over 1 plus e raised to power negative. In this case, what is x1 and x2? 3 and 4. So x1 is equals to 3, x2 is equals to 4. So it's going to be 0 times 1 plus 0 times 3 plus 0 times 4 equals to 0.5. And to be honest, just so that we don't end up wasting time, the last one will be the exact same value. It's just this time we'll be using x1 as 5 and x2 as 6. Those were input features, and the answer will still be 0.5. This will simply solve with our Jacobian matrix. But now you should know that this kind of changes what this x will look like. So x will be equals to, we simply just add those bias terms here. So to accommodate for theta naught, 5 and 6. This will simply be the new matrix, input matrix x. It doesn't change anything. So now to solve for the gradient descent cost function, for change in j, for j equals to 1, oh sorry, j equals to 0 at this point, j equals to 0. So here we become theta 0, theta to be equals to 1 over m depends on the number of data points. In this case, is 3. So 3. Now open your bracket. We have gotten this value at this point, so you can see it here. It's going to be 0.5 minus yi. In this case, that will be the first row because it's I forgot to write from I equals to 1 to about wherever you can reach. So starting with I equals to 1, that will be the first row. I told you that I is row and j is column. So it will be minus 0 times, don't forget this one. So in this case, I is what 1 and j is what 0. This is simply say look into row 1 column 0. What is that? Row 1, this is row 1 column 0. So 1 times 1 plus 0.5 minus 1. In this case, this will be y equals to 2. I equals to 2. So this will be the second data we'll take times this will be x to 0. So look into row 2. That's this point. So it's going to be still times 1. Then plus 0.5 minus 1. That's the third row times 1. That will simply be an answer. If you solve this, you're going to get about minus 0.167. And let's be honest, approximately this is approximately 0. So for j equals to 1, when you want to get the gradient of the cost function, so this will be 1 now. It's still going to be 1 over 3. But in this case, we're using the second data point, which we got here. It's still the same 0.5. So 0.5 minus, in this case, yi is still the same, 0. Now it's xij that will change. In this case, it will be x1, but then j is equals to 1. So row 1, column 1. That is what we'll take as this. So this was 0, 1, then 2. So in this case, it should be times 1 plus 0.5 minus 1. It's still the same distance that's going on here. Times 3 in this case. Plus 0.5 minus 1 times 5 in this case. If you solve this, you're going to get that this is going to be 1.167. And then lastly, for j equals to 2, you're trying to solve this out again. It's going to be 1 over 3, 0.5 minus 0 again, times the third column this time. This will be 2 plus 0.5 minus 1 times 4 in this case, plus 0.5 minus 1 times 6 in this case. So if you solve this, you're going to get answer as 1.333. So you can simply say that the new values now, this is theta 1, 0, theta 2, 1.167, and the last one is, sorry, is minus 1.167, and this is 1.333. We can say that these are the new updated theta values. Now you can do another iteration with knowing what theta not 1, 2, and 3 is. So I'm just going to stop here, but you can do it if you want. Thank you for listening, and please don't forget to like and subscribe. And also, sorry, this is actually minus, not plus, so minus 1.333. Thank you for listening.